Okay, this is number 3 from the most approachable question. We're given a function and we're given its graph from -1 to 6. We're told some information about it. We know that the x-intercepts are at 0 and at wherever x equals p. We're first asked to find where what x is p, right? So we're given the function. This is paper 2. Graph the function. So if I go and I create a graph here, and I insert my values, sorry, this is x to the 4th minus 54x squared plus 60x. Now, it looks a little bit different than what they had, but remember, they only had from -1 all the way through. So I'm going to do menu and do some window zooming. Let's do some window settings. We know that this is probably an absurd number. So let's go to 500 and let's go to -200 and see what happens. There we go. So that looks way more like my original graph, right? My original graph, something like that. There we go. We've got it. So all we have to do is figure out where the heck that is. So menu, analyze graph. We're going to find a 0. So we have 1.14 is our first answer. So because we're told what it is, all we have to do is use our calculator, and we know that the value of p equals 1.14. The next thing, it wants to know where the maximum point is. Well, the maximum point, again, this is a calculator question. Menu, analyze graph, maximum. So my maximum is at 0.562 and 16.A. So I don't remember what that number was. Now we need to find the equation of the tangent of the graph at A. Okay. Now, for this, we need to know what that horizontal asymptote is. If it's A is a maximum point, what's the slope of that line that goes like that? Well, the slope would be 0. So it would be 0x plus whatever that other thing is. So 16.8. So it's going to be y is 16.8. I'm saying 16.8 because that's what I think I saw there. Yeah, it's 16.8. Y is 16.8. Again, boom. Easy marks. Next, we need to find the point of inflection. Okay, now we got to do some calculus. Because the inflection point happens when the second derivative equals 0. So we got to take the first derivative, which would be 4x cubed minus 108. Thank you, IB program. X plus 60. So that is our first derivative. Our second derivative is 12x squared minus 108. And all we have to do is find out where 12x squared minus 108 equals 0. So 12x squared equals 108. X squared equals 9? Yeah. So x equals plus or minus 3. However, we know that it's positive. So it's when x equals 3, that is the spot where that is. That's where our inflection point is. So from there, we need to figure out where that point of inflection is. I'm going to do the lazy man's thing because I have a calculator, and I'm going to do menu, analyze, or sorry, I'm going to do graph trace, and I'm going to trace this, just type the number 3, and that tells me what the what the y coordinate is. So I know that B, for some reason my iPad is not updating. So that point B is at 3, -225. So now I've got a point on the line. I just have to evaluate the first derivative at 3. I'll know the slope of the line, and then I can solve for that. When we find the rate of change at B, well, sorry, we're finding, what am I finding? Finding the coordinates of B. Nailed it. Find the rate of change of f at B. So the rate of change of f at B is just going to be substituting in 3 here and here, and we'll get our answer. So if I did that, let's go back to a calculator page. So I've got 4 times 3 to the third. Thank you, so helpful. Minus 108 times 3 squared plus 60. And grand reveal, that is the rate of change. All right, I think with that, hopefully you see, you can use your calculator to do a whole bunch for you. Interestingly, if you want, on your calculator, we know that that's the point. I can also do menu, analyze graph, and if I do escape, menu, what do I want to do? dy dx, and I want this at 3, I get my value of what that is. So I made a mistake somehow. How did I make a mistake? Oh, because it's 108. I screwed it up here. I did 108, I did 3 squared. Haha. Where did it go? I screwed that up. I want that to be to that. So negative 16. And that's what we saw when we looked at it here on our graph. We had negative 156. Okay, hope that's